Hello everyone, welcome back to our Generative AI series. In our previous lecture, we explored the core components of LangGraph including state, nodes, edges, human in the loop, tools and LangSmith. By now, we understand what each component is and why it exists, but understanding the component individually is only half of the journey. So, the real power of LangGraph comes from how these components will work together to execute an intelligent AI workflows. So when a user send a request, how does LangGraph decides which node to execute first? How does it know when call to LLM model? Okay, when to invoke a tool, when to loop back and retry mechanism, right? When we it have to go for the retry mechanism, how can multiple agents collaborate together to solve a complex problem? So these are exactly the questions we'll answer in today's lecture. So by the end of this session, we'll understand how a complete LangGraph workflow execute, how it scales for enterprise application, and why graph-based orchestration has become the preferred approach for building modern AI applications. So without any further delay, let's get started. Workflow of LangGraph. So this workflow is taken from one of LangGraph's official agent architecture. Don't worry about memorizing every node. Our goal is to understand how LangGraph control executions. Okay, so we'll start with the start point. Okay, so it means every LangGraph application will be beginning with a special node which we called as a start. So start is not an any AI model or agent, it simply makes the entry point of the graph. So from here we are entering into the graph mode. So execution that moves from start straight into the assistant node. So from start it will go to the assistant node, right? So it will go to the assistant mode now, which is where the real decision making will start. So user will give a prompt or it will start that. So when we'll start it, it will go to the assistant mode. So we'll see for the assistant, if we'll see here it mentioned as a manager or a router. So user request is sent to the assistant node. Now from start it went to the assistant node. So this is the central node for managing overall workflow. It controls the movement between tools and sequences based on the current state. So one node is storing a data for the another node. So this is the central node for managing all the over workflow. It controls the movement between tools and sequences based on the current state. So we can think of the assistant as a manager of the workflow. It doesn't perform every task itself. It decides who should perform the next task. So the assistant usually contain the reasoning capabilities of the applications. So if it analyzes the current state, understand the user request and decide what should happen next. So it is taking all the decisions according to the reasoning or capabilities of the applications. It will just figure it out everything. So for example, should I answer directly, should I call a robot, or should I call a document, or should I need some tools, or we need to ask something to the agent, so should I wait for a human approval? So these kind of decisions will be making by the assistant. So now we came from start to assistant mode. Now after assistant we are writing is needed. So we have to go for the write mode. So when it is moving from assistant to the writing mode, so now we are inside the enter writing sequence. So not every request requires content generation, right? So few of them needed a content generation, but not all the notes over here. So if the assistant decides that writing is required, it route the workflow into the enter write subsequence mode. Okay, so it is deciding that okay, here writing is needed, so I have to move this to the enter write sequence mode. Okay, so user will ask a question, write a resignation letter. So assistant will go or it will enter to the writing sequence and writer agent will write the resignation letter for the user. Then it will move to the write assistant. right? So in the write assistant, this is a specialized module which is just focusing on the writing process. So this module is responsible only for content generation. It may loop with tools for refining or editing before completing the sequence, but this is just responsible for writing process. So instead of mixing every responsibility into a one large agent, LangGraph allows us to create a specialized agent. We do not need to combine two or three responsibilities into the one agent. We can create a different kind of agent. So write assistant means it will go for the write. Okay, so it is just entering to the writing sequence, and here it will write the code, or it will write the letter for us. Okay, so for example, assistant will call a writer agent. Okay, then writer agent, what it will do, it will write the code and it will go for the review. Then again it will go for the assistant mode. So here every time assistant is taking the decision for us. So after that it will go leave write sequence. Okay, so once the writing task is completed, the system will exist the write mode. So now it is done, we are entered in the write sequence, because here it noted it down. Okay, it needs to be written something, so it came here, enter the writing sequence, and then it went for the write assistant. So assistant or agent, it write that, and when it is completed, then it is coming out from the writing sequence mode. So now it is no more in the writing sequence mode, so it is coming out from that. Then writer sensitive tools and assistants. Okay, so assistant tools, so these nodes provide special capabilities. So depending on the state, that agent route tasks to the tools, or it will enhance writing, or it will perform sensitive operations, because maybe whatever the letter it written for us, that is not capable enough to show us, right? So what it will go, it will go for the enhancement or performing sensitive operations in that part. Okay, so some operations are sensitive and shouldn't be executed directly by the assistants. For example, sending email, deleting files, database updates, payment APIs, etc. Right? So instead, the assistant route these requests to dedicated tools with proper validation and permissions. Okay, so if we'll see here, we have a write sensitive tools. So if we are going for writing assistant, it will call for the some sensitive tools, and back and forth, right? How many it want, it will go and call these tools. And then if we'll see here, leave write sequence, and it is going back to the, if approval is done and sensitive operation result back, will it will be coming to the assistant, and assistant is going to decide whether it need any assistance tool over here, or it needs to going to send that response, and it means we are coming to the end process. Once every required node has completed successfully, their executions will reach to the end node now, right? So the process concludes once the desired outcome is achieved. So now we have desired outcome with us, so and all necessary tools have been executed, all the part is done over here. So at this point we'll get the final responses, and it will return to the user and workflow will terminate. So just now we saw, right? So if we have approved, done, approved, it means done. Okay, so it will come here, and assistant will see, okay, this is already approved and done, so it means we have to end this process, so it will end that process. But if something is trouble over here, it will come here and it will decide, okay, we need to write it again it will go for the write loop, and it will follow till the time will not get the proper response, but at the end it will come to the end node and our task will be terminated. For example, user will start, okay, user some ask something and it will start that flow, and it will go to the assistant. Okay, assistant will have search documents and writer. Parallelly they have both, right? Search document and writer. So according to the tool selection, or according to the assistant decision, whether it will go for searching the tools or it will go for the writer. So if it is going for the search document, it need to retrieve that documents, because it is going for the search, so it will retrieve all the document, and again it will send to the assistant to decide what needs to be done over here. So when it will coming to the assistant, assistant is going to decide what needs needs to be done with these documents which it got searched. Then at the end, when it will be decide, right, when it process will be done, it will be sending to the in node. So same way for writer, just now we saw it, right? So for the writer, it will decide what needs to be done over here, and then it will go and generate that document or generate that later, and at the end it will go for the assistant whether further enhancement we needed it over here or we need to end it. So assistant will decide according to the result from this phase or result from this phase. So here assistant is deciding in which phase or in which part it have to go. Then how LangGraph is scaling. Okay, as AI application become larger, a single agent quickly become difficult to maintain because maybe it have more and more responsibilities. When our application will be larger ones, we are providing a responsibility to one agent, and it will be difficult to analyze for that agent. Okay, or it is very difficult to maintain it. So LangGraph solves this by representing that application as a graph, or we can say as a independent nodes. So since each node has a clear responsibilities, or application become easier to extend, debug and scale because everyone have only one responsibilities and they are doing or performing their own tasks, and then enhance decision making. So the relationship between the nodes will help that AI agents to learn from the past actions and feedback. If there is no relationship between two nodes, that we cannot get the data for the past node because there is a no relationship between node A and node B. So we have to make a relationship between the node A and node B. So whatever the decision is coming from the node A, we can get it for the node B. So that node A output is the input for the node B, right? So we have to enhance that process, or we have to enhance the decision making over here. So we do not need to start from the scratch because we already have that information and we are going to utilize that information. Then increased flexibility. So if it will let the developers integrate the new flow or adapt the existing flow easily because these are the nodes. We can make a connection between them. It will be easy for developers to integrate it. So that's why it is very flexible. Then multi-agent workflow. Here we can solve the complex task using this multiple agents. So we can create different tasks using a agents, right? We have to create a dedicated agent for each task. So if we have to route the agent to the specific task, so it will help us to run the task parallelly and efficiently, handling the diverse workload. So here everyone have their own responsibilities or roles or tasks, so they can go and perform their own task. They don't need to bother about the other nodes or other agents. Then decentralized coordination. Instead of one giant agent is trying to do everything, each agent handle its own piece of work and manage its own state. They don't need to bother about everything and everything at a time. So they can handle their own piece or their own states. So there is no single bottleneck to coordinating every decision over here because they are performing their own task. So multi-agent will create a scalable system for us where automation doesn't rely on the one system, but that is distributed across a coordinated network of agents. So we'll have multiple agents over here. We do not need to rely only on the one agent for this process. Then now, why we used graph based orchestration over here? So why we didn't just use if else block instead of this graph? So you should do this for a small scripts. We can do it for the small scripts, but it breaks down fast one the agent start growing in complexity. So for now, suppose if we are writing it like that, if, then another if there are if else block, right? So nested if we are writing it over here, and we'll write the if else block instead of here graph, right? So when agents will grow, graphs will help us in a below ways. So first is full visibility into what ran. So we can draw the graph, trace every node that fired and pinpoint the exact spot where things went sideways. So try doing that with 6 level of nested if else. It will be very difficult, right? So in place of if else, we are going to use the graph. So for us it will be easy to trace that and pinpoint what is the exact spot where things are not working as expected, or where in which node things are failing over here. So we can trace it very easily. Then save, pause and resume. So LangGraph, it will have some checkpoints. So the full state at every node. So there is a some checkpoints for us. So our agent can freeze mid run. It will stop in the mid run and wait hours for a human to come and approve it. So it will wait for a human. Okay, so it is here waiting for a human approvals. So it is saving that data, pausing for a moment or 1 or 2 days, and then again it is going to resume that operations. So it is pausing for a some time, and then it will collect document. Suppose if we are collecting a document, then manager will approve it. Okay, so till the time manager will not approve it, we have to wait it over here, because till now we are not getting any approvals. Here approval is needed, so it will wait or it will pause for a moment. So it will check state. Check pointed process can be ideal for hours or days. So according to our configuration, it will wait till that time because it needs human approval. If it will not get it, it will not move. When it will get the approvals, when manager will approve that process, then it will continue the execution. So first it needs the manager approval, and then it will go and execute the process. Okay, build in stream. So because each node here is a separate unit, so LangGraph can push results out one node at a time. So user sees progress as it happens, not just a final answer. So we can go for the streaming over here. So one process is completed, it will send the some response, so user will aware about that, okay, something is working over here. So without streaming, what will happen is it is just loading for 30 seconds or 1 minute, and at the end we'll get the answers. So with LangGraph, what will happen is it will go for the searching. Okay, so user know, okay, this is in the search phase. Then it is reading a PDF, so it will show that PDF, it is reading the PDF. Then calling a tool, so user knows that, okay, it is calling the tools. After that it is generating the answers and user will get the answers. So in this phase it is done. So here in every phase user is also aware what is going on and whatever the things it is calling in behind. But without streaming we don't know what is calling inside here. It is also here doing same thing, reading the PDF, calling tools, generating answers, but we are not aware about this part over here. So that's how built-in streaming is helping us over here. Then user will see the progress immediately. Okay, so here if we are starting it and we are going for the search process. Okay, so if it is evaluating some sources for us, then if it has enough resources, it will go and summarize that resources and we'll get the result with us. Okay, so it is going for the end one. So it is going to evaluate that process, it will refine our query, and it will go for the search engine, where it will again it will refine again. So if it will not getting it, so not enough resources it will have, it will go for the refining that query, and it will refine and again loop back to the search. So now again we are searching that process till the time it will not have enough sources to search it, it will go to the back and forth. Okay, it is going for that flow again and again, and when it will have enough information, enough sources, it will summarize that information and will be ending. That means we'll be getting the response. So this back and forth process is impossible in chain. So in the graph it's just another edge. There is no issue with the LangGraph. So today we explored how LangGraph execute intelligent workflows, how different nodes collaborate, and why graph based or orchestration is essential for modern AI agents. But understanding the workflow is only the first step. In the next lecture, we'll move from theory to practice and understand, or will build our first LangGraph application from scratch. We'll create nodes, connect them with edges, manage states, and see the complete workflow execution. Until next time, keep learning, keep growing, keep building. I'll see you in the next lecture. Thank you.